Hi, in this video we're going to talk about linear functions and exponential functions. These are two specific types of functions that come up very frequently in everyday life, so we give them special names so that we can refer to them easily. There are lots of other functions out there. Keep in mind, you already know what the definition of a function is, so you can tell if some graph that you see is a function just using the knowledge that every input has one output, or using the method of the vertical line test, which I hesitate to even state because it's devoid of meaning. Sometimes it makes us forget what a function actually means. Okay, so these are two specific types of functions. Linear functions look like straight lines. Exponential functions are curves. Now, there's no such thing as a curved line, so don't call them lines. Not every function is a line. Only linear functions are lines. This is the general form of a linear function. It looks like y equals mx plus b, or you could write it as y equals b plus mx because addition is commutative, so you can put the starting value first and then the x value, or you could put the x value first and then the starting value. It doesn't matter. I tend to write it like this more often because it makes more sense to me. This is another general equation of a line. I don't use this version as much, but if you're familiar with it, you're of course welcome to use it. So I'm just listing it for completeness, but I use y equals b plus mx most often. In this general equation, m is the slope or the rate of change. That means how quickly the y value is changing as x increases by 1. And the b is the y-intercept, which is the same thing as the starting amount of whatever your dependent variable is. So I'm going to write some of those notes, what I just said, up here. So the slope or the rate, this means, and it means the same for any function, it is how y changes as x increases by 1 unit. Okay, so that's really important to understand the definition of a slope, and that's the definition of a slope. And then b, the y-intercept or the starting amount, that's the starting amount of the dependent variable, the y variable. We're going to spend a lot of time talking about these things, not in this video, but over the next few weeks. We're going to spend time unpacking what these terms mean in real life situations to make it easier to understand. Exponential functions take on a different form. So linear functions have everything on one line, like everything is multiplying or adding there. Exponential functions have an exponent, hence the name exponential functions. And the exponent is the x, or the independent variable, whatever you want to name it. So they take the form y equals a times b to the x power. So that puts the x in the exponent. In this setup, and I don't know why we use b in both cases when they mean different things, so be careful with that. The b in linear functions means the starting amount, whereas in exponential functions, the a is the starting amount, that's the starting value, and the b stands for the factor, or the base of that exponent. Again, we'll talk more about this, so just make sure you have these in your notes as we're introducing these functions. Now, I've given two examples here. One is a linear function, and the other is an exponential function. And we're just going to sketch a graph of what they look like. So y equals 4 minus 2x. That is a linear function because it looks like b plus mx, where b is 4 and m is negative 2. And some people like to write this as negative 2 over 1. And I'll show you why. So b is 4, that's the starting amount in terms of the y. So start up here at 4. And then the slope tells you how quickly or how steep to draw this line. If it's a negative value, that means it should be a decreasing line. When you read it from left to right, it should be falling. If this were a positive value, then this would be an increasing line. So this is negative, and remember what the slope means. It means how does y change as x increases by 1? So if you are given a whole number, we know that any whole number is the same thing as just dividing it by 1. So negative 2 over 1 is the same thing as negative 2. So the reason why people like to do this is because some people have learned slope as rise over run. And the reason why that interpretation makes sense is because if your slope is negative 2, that means as x increases by 1, you should fall 2 units. And that's what this fraction means as well. That's why some people have internalized this as rise, or fall in this case because it's negative, fall 2 units and run 1. So here's your rise or fall 2 units and run 1. Okay, so the point is negative 1 comma 2, and then you just connect those 2 points, roughly looks like that. So it should be a straight line. I'm not very good at drawing straight lines, but it should be straight. So that's just one example of a linear function. And you can see how we did this. We started off with finding the starting amount, which is the b value. And then we found the slope, which is the m. It's the number multiplied by the x. It's always the number multiplied by the x. Whether you see it first, like this, or whether you see it second, like this, these mean the same thing. So pay attention to what number is being multiplied by the x, because that is your slope. This is an exponential function, so let's do this example. In this case, 4 is your starting value, so a equals 4. That's your starting amount. So that tells you where to draw your first point. It should be right here at 4. Same thing as the linear function. It's also 4. The b value is 1/2. That is your factor. That tells you what you multiply by to get to the next value. So linear functions focus on addition. So I'm going to kind of make that note here. Addition or subtraction. Exponential functions focus on multiplication or division. So this b value is telling you to multiply each y value. So let's take your starting y value. Let's start there. Let's got to start somewhere. So let's start with the starting value. Start with 4. Multiply that by 1/2, and you should get 2. That'll bring you down here. If you multiply 2 by 1/2, that'll bring you down to 1. And if you multiply 1 by 1/2, that'll bring you to 1/2. A half times a half will bring you to a fourth, and so on and so on. And so you can see that this is not a line. It doesn't look like a line. It has a curve to it. So this function looks more like a C, or maybe not a C, a soft L. It's like a soft L. That's what it looks like. And so the way we graphed this is we started with the starting value, the initial value of 4, and we multiplied that y value by 1/2. As x increases by 1, we kept multiplying y by 1/2. Wow, tongue twisted there. Okay, so every time x increased by 1, we just kept multiplying by the same factor. And notice that's why it's called a factor, because you're multiplying. And so when you hear the word factor, you should think of multiplication, right? Like the factors of 6 are 2 and 3 and 6 and 1, because we found them by thinking about what can you multiply to get 6. So factor, this means multiplication. Linear functions focus on addition. And when I say multiplication, I also mean you could think about that as division, because multiplying by 1/2 is the same as dividing by 2. So I tend to just focus on the multiplication aspect, and I tend to just talk about addition instead of subtraction, because addition covers subtraction. Addition is, it's addition of all positive numbers, and subtraction is just addition with negative numbers. So addition covers everything to me. The last thing I wanted to show you was if you see this in a table. So if you saw a table of values and you were asked, does this table represent a linear function, an exponential function, or neither? Then one thing you should do is first make sure that all the x values go up by 1. This is the key definition here. You have to make sure that the x values are increasing by 1. So look at the table here. This goes up by 1. From 0 to 1 is an increase of 1. From 1 to 2 is an increase of 1. But from 2 to 4 is an increase of 2. So we have to pay attention to that and take note of that. I did the same thing in this table. So x is going up by 1 initially, but then it changes and x goes up by 2. So pay attention to whether the x values go up by 1 or not, because the definition of the rate of change is as x increases by 1 unit, how does y change? Now, once you can figure out what happens as x increases by 1, if you are adding the same y value every time, then it's a linear function. If you are multiplying by the same base every time, then it's an exponential function. So we're going to do these examples right now. So from 5 to 7 is a jump of plus 2. And from 7 to 9 is also a jump of plus 2. So that looks good. It's starting to look like a line. It looks like it has a constant slope of plus 2 each time. But then here there's a bigger jump of plus 4. But that's okay because x jumped by 2 here. So if we wanted to know what happened in the middle when x was 3, this value is missing, right? It's not listed in the table. If you wanted to figure out the rate of change, then you could just do 4 over 2, right? If you jumped 4 over an interval of 2 and you want to know what happens in just 1 unit of x, then you just cut that in half and you'll figure out what happens in the smaller jumps right here. That's why the slope is found by doing rise over run, or why it's found by doing, have you ever seen y2 minus y1 over x2 minus x1? That is what we just did. I just did y2 minus y1 and got an increase of plus 4. And I did x2 minus x1 and got an increase of plus 2. And I divided them. Why did I divide them? Because the definition of the slope, or the rate of change, same thing, is how does y change as x increases by 1? So if x is jumping by 2, then just cut in half what y is doing. That way you can figure out what's happening in just the 1 unit. If x was jumping by 3, you would cut the y increase in thirds. If x increased by 10, then you would cut the y increase by 10 to figure out what happens in 1 unit. So it should make sense to you intuitively why we're dividing there. It shouldn't have to be something that you memorize. Of course, you can use this formula on any assessment, but it's good to know that you don't really need to memorize this. It should make sense. So 4 over 2 is the same thing as 2 over 1, which is the same thing as 2, and so the slope is consistent all the way throughout that table. So this is a linear function. If you wanted to write the equation of this line, you could do so. The equation of this line would be y equals the starting amount, which in this case is 5. So right here, there's your starting amount. It's where x is 0. Starting amount, or your b value. So we got 5, and then you're adding 2 each time, so plus 2x. Now remember, I said I tend to do y equals b plus mx because that's what I'm used to seeing it like that. That way makes the most sense to me. But you could write this as y equals 2x plus 5, and you would still be correct. It's just a different way of writing the same thing. Now over here, with exponential functions, this is going up times 2 each time. Although right here, it's going up times 4. But there's a jump of 2 over here again. So that's okay, because now if you want to figure out what happens in these smaller jumps, instead of dividing by 2, you're going to square root to figure out. So your base here is the square root of 4, which is also 2, which we see is consistent for this exponential function. This is a little bit more complicated because the key here is the multiplicativeness. So if this were a jump of 3, you'd have to take the cube root of that y difference. So that's going to get a little bit more complicated. We'll talk about that later after we've been more exposed to the idea of an exponential function. But just keep in mind, you have to pay attention to whether the x values are increasing by 1, because that's the definition of a rate of change. Now, if you want the equation for this function, this is an exponential function. The base is 2, because you're multiplying by 2 each time. The a value is 5, because that's your starting value. It's right there. It's where x is 0. So the equation of this function is 5 times 2 raised to the x power. Okay, that was a lot, but now you have a nice brief overview of both of these types of functions. And throughout the week, we're going to talk more specifically about the various attributes of each function, and we're going to solve some real-life problems that can be modeled using these two functions.